In this section, we're going to continue on with stoichiometry. But as before, we had our quantities in moles already. But most of our scales, they measure in grams. So what we need to do is we need to get them into moles, and then we can use stoichiometry. Alright, let's take this example. 25.0 grams of ammonium nitrate, having a molar mass of 80 grams per mole, will decompose into how many grams of water that has a molar mass of 18 grams per mole. So here's our problem. We have 25 grams of ammonium nitrate, and we want to know how many grams of water that'll produce. So I wrote it up there near the equation. It's a nice way to keep yourself organized. So what I'm going to do first is I'm going to take this 25 grams of ammonium nitrate and get it into moles of ammonium nitrate. We do this by dividing by its molar mass, which you should have seen in previous topics. So we have 0.313 moles of ammonium nitrate. Now we just use our stoichiometric ratio. Notice that we have 2 moles of water for every 1 mole of ammonium nitrate. So we're going to multiply 0.313 times 2 over 1 and give us 0.626 moles of water. Well, if we want to know the mass of water, then we just multiply those moles of water times the molar mass of water, and we get 11.3 grams of water. Now, just to show you something, due to the law of conservation of mass, we cannot start out with 25.0 grams of a substance and end with 11.3, but we can use it to figure out how much N2O there is. It's 13.7, because the 2 products on the right have to equal the 1 reactant on the left in terms of mass, not moles. Here's another example. How many grams of copper 2 sulfate with a molar mass of 160 grams per mole will react with 1.50 grams of aluminum? So here we go. We have 1.5 grams of aluminum, and we want to know how many grams of copper 2 sulfate will react. Well, let's first get our aluminum into moles. We take the mass and divide by the molar mass, and we get 0.056 moles of aluminum. Then we're going to use our stoichiometric ratio. Notice there's 3 moles of copper sulfate for every 2 moles of aluminum. So 0.056 times 3 divided by 2 gives us 0.084 moles of copper sulfate. If I need to get that into grams, I take those moles and I multiply it by the molar mass of copper sulfate, giving us 13.4 grams of copper sulfate. Last example, just to solidify it in your mind. To make 30 grams of sodium chloride, how much magnesium chloride should be used in the reaction? So we set up our problem and what we're trying to solve. We're given 30 grams of sodium chloride, which is how much we want to produce, and we want to know how much magnesium chloride we need. Notice I put the units in there, grams as well. So our first step is to get our grams of sodium chloride into moles by dividing by the molar mass, giving us 0.517 moles of sodium chloride. And then I'm going to use the stoichiometric ratio. There's 1 mole of magnesium chloride for every 2 moles of sodium chloride. So half of 0.517 is 0.259 moles of magnesium chloride. In order to find out the mass of magnesium chloride, I take those moles and I multiply it by the molar mass, and it gives me 24.6 grams of magnesium chloride. And there's our answer. If we need to produce 30.0 grams of sodium chloride, we need to use 24.6 grams of magnesium chloride.